Hello friends, welcome back to my YouTube channel. This is Ramdas Pandit Bharsat, working as Assistant Professor in Chemistry at Maratha Vidyaprasad Samaj, Nasik. In this video lecture, we are going to see the next topic, that is chemical equilibrium. This is the second lesson for you. Now we have to see in detail about it. Right. So first of all, we have to see the introduction part of this lesson. In that, you will see this lesson is generally based on second law of thermodynamics. So it gives the condition of spontaneity with the new functions entropy. So in this case, we should know what is meant by entropy. If you will see what is by entropy, so that is the measure of the amount of energy in a physical system that cannot be used to do work, right? Now you will see if the spontaneous process only to an isolated system, so that will be the entropy is denoted by capital S, and delta means the something is changed there. So change in entropy is greater than 0 for isolated systems only, right? And it will be the spontaneous process, very immediate process. Now the total entropy change, that is the entropy changes in the systems as well as that of the surroundings. Okay, we have know what is meant by systems, what is by surrounding, so that the entropy will change of that system as well as surrounding, right? Please. The isolated systems would be preferable to have criterion that could be applied to the systems itself without having any changes in the surrounding, right? There is no any kind of change in the surrounding because there is the isolated systems, right? Now it can be developed the process such as phase changes and chemical reactions that occur at constant temperature and constant pressure. If you will keep that two conditions as a constant temperature and pressure, so there will be the some changes will be there, that will be the solids, liquid and gases phases changes, right? And chemical reaction will be changed there, right, in this kind of process, and that we can express into this equation. G is equals to H minus Ts, and G stands for, we have know that is the Gibbs free energy, and the H stands for that is enthalpy, right? And T stands for the temperature, and S stands for entropy, right? Temperature for the system, right? S means entropy, right? So like this we should know the meaning of this term. So, and it is the state function. Gibbs free energy is the state function, and in this case only changes in a Gibbs free energy of a systems for a processes occurring at constant temperature and pressure. The changes in Gibbs free energy, that is like this, you can see delta is showing something is changes there. Okay, change in Gibbs free energy is equals to change in enthalpy minus T change in entropy. So in this way we should know here it will be the spontaneous process and the Gibbs free energy is less than 0. Now we have to see when the Gibbs free energy will change in a chemical reaction. So the thermodynamic function uses as the criterion for the spontaneity of chemical reaction is the Gibbs free energy of reactions. Okay, so Gibbs free energy, change in Gibbs free energy is denoted by delta capital G. This quantity is defined the difference in molar Gibbs free energies, that is denoted by capital G at the base small m of the product and the reactant. If you will consider any kind of reaction, so there will be the product and reactant. Okay, so there will be the product and reactant. So you can say here this is the one of the reaction A small a capital A plus small b capital B. It gives small c capital C plus small d capital D. So this one are the reactant and these ones are the product. So this reaction we can write in this way: delta G is equals to, in bracket, small c G at the base C plus small d capital G at the base D, and in bracket complete, minus in bracket A capital G at the base A plus plus small b capital G at the base B. So in this way we can write this equation, and in general it can be write as in this way: delta G summation of n at the base P capital G at the base M for the product. Okay, so this for the product, and minus summation of n at the base R capital G at the base M for the reactant. So the product minus reactant, right? And here in this term, Np and Nr moles of each substances in the product and the reactant respectively in a chemical reactions. Okay, so the P stands for the product and the R stands for the reactant. Okay, and Gm, that is the molar Gibbs free energies for these, okay, reactions. Okay, product and reactant. Now we have to see next topic, that is standard Gibbs free energy of reactions. So it is the like Gibbs free energies of reactions, but in terms of standard molar Gibbs energies of the reactant and product. So you will write in this way: delta G G0 is equals to summation of Np G0 M for the product, okay, and the minus summation of Nr G0 M and for the reactant. So that the standard Gibbs free energy of reaction is the difference in Gibbs free energy between the product in their standard states and the pure reactants in their stable state at 1 bar at a specified temperature, right? And also standard Gibbs free energy is defined as the change in free energy that will occur if the reactant in their standard state are converted to the product in their standard state. And that's why the standard Gibbs free energy is fixed quantity for given reactions and does not vary as the reaction proceed. As we know, the one rule for the any kind of reactions, whatever the molecules are present in the reactant, okay, so same amount of molecules will present in the product, okay, any kind of reactions. Okay, so it will be the equilibrium condition will be there. Now we have to see the next topic, that is standard Gibbs free energy of formations. How we can form that standard Gibbs free energy? So we have know that equation: delta G0 is equals to summation of Np delta G0F for the product and minus summation of Nr delta G0F for the reactant. Okay, so you will say the standard Gibbs free energy of formation is the change in free energy that accompanies the formation of 1 mole of that substance from its constituent elements when the substance and elements are in their standard state. So in this kind of reaction, if you are forming the 1 mole of substance from the any constituent of the element, so that times the substance and elements are their standard state, right? The standard free energy of the formation and elements in standard states is always 0, right? There are several ways to calculate delta G. 0 are straightforward. Way is to combine the standard enthalpy and standard entropy data. And in this case, you can use this equation here, delta G0 at the base F is equals to delta H0 at the base F minus T delta S0 at the base F. So in this case, we have to apply this equation for this kind of reactions carried out at constant temperature here, right?